Okay, into provider option C. So the idea here is that a PE in one provider can have an external multi-hop, multi-protocol BGP connection to a PE in another provider. And the idea here is that rather than all of the weight and the state of the targets being handled by the ASBRs, the targets can actually be held by the PEs themselves inside the two providers. So how are we going to do this? Well, we're going to use something called labeled unicast. Labeled unicast, exactly what it says, is a label on a unicast route. There are no route targets with it. And what will happen is this PE is going to advertise its loop back with a label to the ASBR. The ASBR will pass that across, and this labeled unicast route will flow all the way from one provider to the other. Okay, so you can see the labeled unicast go from the PE to the ASBR, across the ASBR, and across to the PE. And you can track that, and you can see the labeled unicast turned on in all of those locations. Okay then, we're going to be saying a bit more about labeled unicast in the next screen, because obviously we're going to have iNet unicast routes, your standard IPv4 routes. Now we're going to have a labeled version of the same route, and clearly we're going to want that in a different table. Okay, so that's the labeled unicast. The second component to this is the external multi-protocol BGP. So what we're going to do is we're going to configure the multi-protocol BGP that up till now has been just an internal protocol. We're going to be configuring that external, and so that the PE in one can connect to the PE in the other. Okay, so clearly this means that one autonomous system or one provider has routes for the inside of another provider, and so there is a fair amount of sharing going on here, and of course you have to be careful as you move those routes. All right then, so what do we have configured here? Well, in our example, as you can see below here, we've made a couple of changes. The first change is we're going to use a route reflector, because that's a really good place to terminate this multi-protocol BGP external session. It means that we just can have one session from the remote provider, and then we can share it as route reflectors do. So that's the first thing. And the second thing is we've shortened the inside of the second AS. Okay, so when we configure the external BGP from router 8 to P21, we're going to be using a BGP group P21. However, when we start to configure this external multi-protocol BGP from the route reflector, we're going to use the group P2 remote PE. Now, we haven't been told very much about P2 remote PE. All we really have is an IP address. And it's quite possible that that IP address is a loopback on P21. In fact, it's very likely. However, it could be another PE inside here. It could be a route reflector. In fact, it could really be anything, because all we know about it is this labeled unicast that's come across. So what we're going to do is, on the termination of my arrows, I'm going to have them sort of ending here in these examples as if PE, remote PE, was located on P2.1. Although do bear in mind that this could be another PE inside the AS. So in a moment I have a screen that talks about the operations of the labeled unicast and how it can clash with the iNet unicast. It's quite a useful screen. But prior to then, I just want to talk about the resolution of these routes and the three label stack that you get with the option C. So it works like this. The PE in this particular AS wants to reach a PE in the other AS to pass VPN traffic. It's going to look in the BGP L3 VPN table, it's going to see the route, and it's going to see it resolving to the IP address of the remote PE, which in this case has come across the external multi-protocol BGP. That IP address is going to be stored in the table with a label, and that label is the labeled unicast. So that label becomes the second label. So we have the inner VPN label, the second label, and then which router told the PE about that particular label? Well, it was the ASBR. And the ASBR, there's an LSP to it, and that becomes the outer transport label. And then as the packet moves, it has three labels here, comes to the ASBR, pops the outer label, has the inner labeled unicast and VPN two label stack as it goes external. And then when it reaches the other end, it re-enters a transport label heading towards a PE if needed, or in our case, probably arrives at its destination.